Hello and good morning, everyone. Yeah, we are excited to tell you more about our cloud-native journey. So it's fantastic to be in this lovely city, Amsterdam, and after this very inspiring lightning talks, Alessio and I are looking forward for an amazing day to share you our experience and cloud-native journey we did so far at Swisscom. So I'm Josh Hiller. I'm a product owner at Swisscom, and I'm very passionate about DevOps and bringing together people and ideas to build innovative solutions. And with me is
Diamanti Alessio, Senior DevOps Engineer at Swisscom. My first time at KubeCon, but I hope I will be able to give you some technical details on how we try to move out from a spreadsheet to everything as code. So let's get it started.
So yeah, back to the title. So first we want to explain, oh no, what's that? Oh no, my teammate put me on the on-call service for our 5G core. So now Ops Jenny is calling me, so I will take the call. Sorry, I missed it. So yeah, Alessio will explain you more about
what's going on. Actually, what's going on here is that someone by mistake probably deleted CCRC, which is our NRF function. Cannot here maybe, yes. As you can see here, there is a CCRC namespace that was created lately in 3 minutes, which means that it was been deleted and now it's back alive. This was on our on-premise infrastructure, and now if I manage to find my mouse, yes, you will see that it's exactly the same situation here for DNRF in AWS cluster we have. So we have a freshly created namespaces. Thanks to our automation, we don't have to worry about that, and we can continue with our talk, and we will see at the end what's the result. So back to you, Josh.
Yeah, so why we are doing this? So first, we really want to improve our time to market, to build new services for our customer. And as well, we want to benefit of cloud elasticity, so we can build our telco workload on different clouds, on public cloud, private cloud. With this, we also want to increase or improve our innovation to build more reliable services that we can operate our services at scale. But all this new technology is arriving, and we need the skills really to be able to manage and build this automation.
Sorry.
So for this, we have our journey from telco to techco, and there we have 4 pillars. So one is really about simplicity. So telco infrastructure or services are increasing in complexity, so we really need to be able to simplify, to be able to build new services or products fast and get them out to our customer. Then the next pillar is cloud nativeness. So it's not about religion, it's really about sustainable operational benefits we want to achieve with the elasticity of cloud. And for this, we also really need the automation. And there, yeah, we cannot use any more spreadsheet. We need to have everything as code, so we have it described in our repository and we can push it to the different infrastructure. And to do this, we also need to change how we work. So it's not enough to be able that someone just knows about a certain capability and the next person knows about the next capability. So we really need to work together to be able to make this automation work. So how we do this? So first, we have one backlog for the whole 5G core we built at Swisscom. And there it really helps to prioritize and as well to share the knowledge between all the different teams. And we really encourage the people to work on tasks of other teams and share their knowledge. So really a boundaryless collaboration. As well, we really take together networking engineers, Kubernetes experts, and application specialists to build this new 5G, 4G core together. And we start to experiment way faster. So we test something, we fail, and then we try it with another solution. So we really try to rapidly find new solutions for the problems we are facing. And the last point is really we have a close collaboration with our vendor. So there we can give them fast feedback and push them in the right direction to build more cloud-native workloads. With this, I want now to go more into the technical detail. So to make all this work and be able to spend more time building new products or services for our customer, we really need to have the end-to-end automation. So we don't need to spend our time on tedious, repetitive work anymore. So to give you a short introduction on our automation pipeline. So first, there's an overarching pipeline. Today we use Jenkins for that. And then we have a few sub-pipelines triggering different functionalities. So we get the package from the software packages from our vendor to our software gateway. From there, we use the sourcing pipeline to check this and monitor if there is any new software, take it, if needed, decompose it, push it to our Artifactory, all the artifacts, the Helm charts, and the images. And then we also do security scans, so we get alarms if there is any vulnerability in this software we receive from our vendors in the end. And then the most important thing, our DevOps team, which manage everything as code in our Git repository. So our full service is fully described in the Git, nowhere else. And then we have our different clouds. We have a public cloud, private cloud, and there we have our Kubernetes cluster. And we use an operator called Flux to go to Git, read the description, what to deploy, then go to the Artifactory to get the Helm charts, the image repo, and then synchronize this to the Kubernetes cluster. And with this, then we fully automatically can deploy our 5G, 4G core. Then if a CNF is deployed, it will notify the overarching pipeline and will trigger some post-deployment step, or then also the configuration, the business logic of the CNF. Also this, Ansible is fetching this configuration from Git and then pushing this over netconf to the different CNFs in the end. And as well, then we have additional pipelines to trigger an element manager or to configure an element manager, a security manager to know about the new CNF, which was deployed, to be able to communicate with it and get the information needed for their capabilities. And then really one of the most important part is our testing pipeline. There we have different tools we can trigger. And there, like for example, chaos testing, which was mentioned before from Litmus. So there we can trigger this after an upgrade, after a config change. As well, we do this continuously testing. We will show you later. And do this to different CNFs or as a system under test or as an end-to-end test. So, and there also very important is our observability capability, where we get all the metrics, the logs. We have as well a dedicated cluster for the long-term storage, where we store all our data. And this cluster is as well managed by the whole pipeline. and then we use our internal monitoring as a service to create the dashboards and as well to create the alarms. Unfortunately, we were not able to hear it before, but that would be Obscene calling me that the namespace of the both NRFs got deleted. With this, I would like to hand over to Alessio.
Thank you, Josh. Thank you for the great introduction. I would like now to go to some more technical details about the Git repositories we have and how we manage them. The first one I would like to talk about is IP low-level design repository, which is one of the milestone change we lately introduced. It's an Ansible inventory where we store all the IP-related information for all the application, infrastructure, and all the tools we use to manage our 5G core. It's really what enabled us to further automate everything else. So as you can see in the left side, we have the Ansible inventory with hosts, which are the Kubernetes clusters we manage that are divided in groups, different groups regarding their characteristics. On the right side, instead, you can see an example of how we store the parameters. So it's a plain YAML file with a hierarchical structure, and it's, as you can imagine, far away from what we were used in the past with spreadsheets, where you have a spreadsheet somewhere in SharePoint with a freestyle structure. Everyone can go there, modify it. Now, if these parameters are stored in Git, you have a centralized way, you have a peer review process to introduce changes, and it's the only and unique place from where you get parameters. The way you can get them is described at the bottom of the slide. So if you are within an Ansible playbook or a Jinja template, it's natively supported with a path and the name of the parameter you look for, and it's as well quite easy for a generic script, like, for example, Python or whatever. You can use the Ansible inventory command piped into a JQ parser and use the path and the variable name to get the value you look for. This is what we do not only for the IP-related parameters, but for all the parameters of application and infrastructure we manage, as I will show later in the next slides. Let me now go into some more details about the code base for our CNFs. As you can see from the top right corner, we have actually at that moment one repository for each CNF we manage. This was not the case at the beginning when we had an all-in-one repository. However, this is not manageable at all. You can imagine the amount of PRs that are coming for introducing different changes in the different network functions. It was not scalable and manageable at all. So we decided to come to a splitted version for each CNF. The structure of each repo is anyway the same one, and is the one that is depicted in this slide. So as you see, the first folder we have is the Ansible folder, where we store the application low-level design. So all the parameters that belongs to the application which are not IP related. It's again another Ansible inventory, where in this case hosts are the different instances of the CNF we manage. In the example, you have CCPC, so the policy control function, and you see all the hosts, all the different instances we have. We store parameters, as I said before, per host, so which are specific of a specific CNF instance, or in group vars, when they are shared across different CNF instances. In the same folder, we have as well Ansible playbooks and Jinja templates we use to produce the configuration and Kubernetes deployment files. So there is Ansible playbooks that fetches values from the different low-level design parameters and populates templates to produce the application files, which are again stored in Git with the structure you can see in the slide. So for example here, we have all the files for the day 0, which are the Kubernetes resources, and the day 1 configuration files, which are the files that Josh showed you before, are pushed via netconf. For what concerns the branching strategy we have in place, we have one branch for each cluster we manage in the different sites. So several branches for each cluster in dev, staging, and production. How merging strategy works is depicted in this slide. So the idea is that when we want to introduce a change or whatever, an upgrade or a new feature, we start clean from a feature branch, and we produce all the files from templates for all the different clusters. So when all these changes are ready, we raise a merge request to move from the feature branch to one of the development branches, so to one of the dev clusters. We perform some tests, which are automated, and when the feature is validated to be working as intended, we move then from the first dev cluster to the other dev clusters. Again, when moving from dev to staging, the same process, a lot of testing. When it's validated, from one stage cluster, spread across all the other stage clusters, and finally, eventually, hopefully, to the production. What is really important here is that with the template, we really gain a lot of velocity, and we reduce the failure rate, because the structure of the thing you introduce, the change or whatever it is always the same, and parameters are gathered from the low-level design inventories. Going now to the infrastructure repo, we have here, we managed, as we said before, two kinds of infrastructures. So we have the on-premise one, which is the one which is deployed through the package we get from our vendor, Ericsson Cloud Container Distribution, ECCD, which is a flavor of Kubernetes deployed on top of OpenStack VMs. Here, in this case, we have as well Ansible inventory, so we store parameters for ECCD in a specific repo, and again, Jinja template and playbooks to produce deployment files, environmental file you may be familiar with for OpenStack, that is then deployed via a pipeline. For the AWS case, we store as well in Git all the parameters for the flow engine step functions that we use to deploy all the needed resources in AWS, so EKS, VPCs, and whatever we need. Going now to another repo, which is the one we called common repo. This is another milestone, let's say, repo, which is kind of glue among all the other repositories, because here we store some common artifacts, like, for example, the Jenkins pipeline we use to trigger the day 1 configuration via netconf. We store as well a bunch of Ansible playbooks that are used to configure some other systems, like, for example, the gateways, the routing, and the firewall rules we need to operate our 5G core. There is as well the definition of the Flux operator, which is the operator, as Josh showed at the beginning, we use to deploy our Kubernetes apps. Just as quick detail, quick info on how we manage the rest of applications, which are different applications, kind of like for the one that we use for testing or for our observability stack. All of those are as well, of course, stored in Git, and they are managed as well the same way as the others. So inventories, Flux, and eventually some Ansible playbooks and pipelines. But how all of this comes together and glue to have what Josh introduced at the beginning? This is what I tried to depict in this picture. So the idea is that at the beginning there is a manual input and introduction of the parameters in the different low-level design repos. At the moment it's manual, but it could be as well automated, like, for example, via an IPAM. When all those parameters are ready, the automation kicks in, like, for example, for the infrastructure, we have a playbook that is pulling information, populating template, producing configuration files, and then again with another pipeline, it's the infrastructure is deployed. When the infrastructure is ready, we have other playbooks that, again, pull the information from all the application and IP low-level design, populates template, and produce configuration files. Day zero files, which are in our language, let's say Kubernetes files, and day one files, so netconf configuration files. Flux now can take those files from the Git and deploys them on our cluster, as well as for some bunch of tools, like, for example, the external secret operator we use to sync secrets from the HashiCorp Vault. Then there is the day one pipeline, which configures via netconf, and when the CNF is ready, a bunch of testing cases are executed. To complete the picture, we have as well some other small repos we manage, like, for example, the one where we define alerting rules, which is one of those alerts is the one that we received at the beginning of this presentation, alarming us that a namespace was deleted. And lastly, this repo here on the upper left side, where we have all the other tools we deployed, as I said, with Flux. After all of that, our automation, I hope, should have worked as expected. And let me now go to see in the dashboard if everything is back as intended. So we prepared this dashboard here for the KubeCon. Then my okay, the VPN, I hope it's working back again. Yes, so actually what you can see from here, this is the Grafana dashboard. So for the with the metric that we get from the cluster, we see that there was a period where of course we lost a lot of pods because the namespace was deleted, and now the situation is more or less back to normal. Unfortunately, we don't have all the NF back registered, but yeah, this is real life. Sometimes it takes time to get all the NF registered back into the NRF. What I would like to show you as well is that I think that we have problems with the VPN, but the idea was to show you here some logs entry about, yeah, it's even worse now. Anyway, there should have been some logs entry about the changes we made, so the netconf configuration that were pushed, and as well some information about the testing. Let me see if I can recover this situation. Probably. It's reconnecting. I don't know why. Really sorry about that. That should have. Okay, yeah. Anyway, let me maybe try quickly, but I will not make it. Really sorry. But yeah. And with that, let's switch back to the presentation for some conclusion from Josh.
So really important there was also that we really are able then also to show the test progress. So you would have seen how many tests were successfully completed after this redeployment. So we don't need to touch anything to get the CNF back or to deploy a new CNF. So that can now be fully automated. And with this is really that basically our conclusion is that automation outruns spreadsheets. So we will not work with text file or something stored on an individual laptop. That's not anymore possible in such an environment. And we really can benefit of cloud elasticity, especially if the workload supports it, that you can deploy it wherever you need it. It's important to have this low-level design as code and a smart repository structure. And yeah, you need to bring together the good engineer from all domains to build really to figure out the best solution for the problems you need to solve, which really is able to then transform with the technology. So for us, we have started the our journey from telco to techco. And yeah, with that, thank you for listening to us. So if there is still time for a question, or we can move to the next talk.
I was checking about the possibility to ask the questions. The audio setup doesn't allow that. That's why I'm going to play this role. Thanks for this presentation. Very insightful. I am quite curious, how do you tie this in, for example, the change process with the merge request, promoting from environment to environment into your existing well-established change management process in the company?
So that's have not been done yet. So there we try really to go new ways. We are working with our change management to see how we automate changes and which changes really need to go through this change process and what's just done automatically. Because yeah, with how we work now, it's not possible anymore that someone understands why this change is now going to production and even have the time to click somewhere to accept it, or even ask someone why this now needs to go to production. We really want to get to a change capability where we bring like 20, 100 changes a week or even a day to production. So it gets impossible to know exactly which change is really doing. And there we also think that because we have this structure and all the testing, that we are very confident that everything which gets pushed to production is not breaking something.
Thank you very much. Thanks, Josh, and thanks, Alessio. Next on the stage, please give them a round of applause.